So, good afternoon everyone. I am Hari Ganesh from Metro Motor Lab. So, here my colleague Chandra Kumar. So, today we are going to explore more options of electrochemical workstation and how it is used in area of battery corrosion. So, we have set up 3 different practical sessions today to concentrate more on battery and basics about electrochemical workstation. So, any electrochemical workstation or any research, we will be doing CEV, cyclic voltammetry, and EIS, electrochemical impedance, and then we will be doing charge discharge. So, this three workstations we have planned to give the basic idea about electrochemical workstation, what it does, what kind of information it gives, how it is useful for your research. So, to start with, I will go with very basic. What is electrochemistry? It deals with electrical as well as chemistry. So, by applying potential or current, it changes the chemical property of your substance. So, thereby we are calling this as a electrochemistry. So, this instrument is called as electrochemical workstation to study the electrochemical properties or characterization or behavior during the process. So, there are 2 modes, one is P stat, another one is G stat. P stat is potentiostatic mode, where we will be applying a potential and we measure current. In galvanostatic mode, we will be applying current and then we will be measuring the potential. So, in the market, if someone is telling electrochemical workstation with P stat, then you can do only potential and you can measure the current. Vice versa is not possible. If someone says my instrument has both potentiostat as well as galvanostat, then only both vice versa is possible. So, blindly do not believe what the electrochemical workstation it is. You should ask whether it is having both potentiostat as well as galvanostatic mode. Then only you can apply the current and you can measure the potential, otherwise those modes are not possible. So, all our Metro Motor Lab instrument has both potentiostat as well as galvanostat in all our equipments, starting from basic to high end equipments. So, how we study this reaction? We need a electrochemical cell. This electrochemical cell is consist of 3 electrode or 4 electrode or 2 electrode setup. So, the common one what we use is 3 electrode setup, which has working electrode, reference electrode and counter electrode. So, we apply the potential between working and reference and we measure the current between working and counter. This is the common phenomena in all electrochemical workstation. So, when you are applying a particular potential, so we need a reference potential. Against that reference potential, instrument applies the potential to your working electrode or your substance. So, that reference potential is given by reference electrode. So, depends upon the electrolyte what you fill, 3 molar KCl or saturated calomel, mercury mercurous chloride, depends on that the standard potential value will vary. So, depends upon the analysis or depends upon the material, we can choose different types of electrolyte, reference electrode, whether it is a silver chloride electrode or calomel electrode, depends on the work, it varies. And working electrode, normally we have different types of working electrode ranging from glassy carbon, gold, platinum, different metals surfaces as carbon foam, copper foam, different working materials are available. Sometimes working material can be directly your sample. If you use GC electrode, the GC electrode is not the working electrode. On top of the GC surface, you will be coating your substance. So, your substance is going to be the working electrode, but the GC electrode gives the support. You will do the drop cast or you just deposit on the surface of the electrode and then you study it. So, normally the counter electrode size should be 3 times greater than the working electrode size. And this is the basic requirement for many of the experiments. When you are doing a corrosion experiment, if you are exposing 1 centimeter square of your sample, then your counter electrode should have at least 3 centimeter square of surface area to measure the changes in current. So, some experiments are very sensitive or the current changes are very minimal, so that only with the bigger counter electrode you can get better signal. But if you do the normal, you have done CV in the first session. So, in the normal CV experiment with the ferric to ferro or ferro to ferric, you have seen the counter electrode. What electrode it is used? Platinum wire. So, there it is, the surface area is very minimal. So, same way you can use a platinum sheet or platinum coil electrode, or sometimes graphene rod can be used as a counter electrode. So, normally counter electrodes are noble metals which will not participate in your reaction, but used as a current collector. So, to do this electrochemical studies, we have different types of equipments, not only Metro Motor Lab. In the market you can see different types. One is handheld equipment or portable equipment they say, another one is compact equipment, another is a modular or high end equipment, and then last but not the least multi-channel equipments. So, each instrument varies with respect to the current and voltage as well as the compliance voltage. So, every instrument has some minimum specifications. So, based upon that, the cost and the ease of application, range of application you can cover, everything will change. So, in case of these smaller equipments, the potential and currents are very minimal, plus or minus 4 volt, less than 100 milliamps current only it produces. So, by using this equipment, you can do normal corrosion experiments as well as biosensors. For those applications, you do not need a higher current, but if you are working on batteries or supercapacitor, then you may need a higher current. You may have to go for a next level of instrument where current is higher. So, before choosing a proper instrument, you should know for my application what kind of instrument I should select, what my instrument should have the basic requirements. So, right now you are considering the voltage as well as current. So, there is another parameter called compliance voltage. What it is? Any idea? So, we are applying a potential to our working electrode, but this working electrode, reference, counter, everything is immersed in a solution. So, your solution also draws some current, depends on the electrolyte, if it is a water or if you are using organic solvent, acetone or different chemicals, that chemical will also absorb some current. So, that we call it as a ohmic drop or IR drop. So, what we do is, for an example, if your solution is consuming some 5 volt, but if you want to apply 5 volt to your working electrode, instrument will apply 10 volt, so that to compensate your solution and then exactly 5 volt to your working electrode. This is called, you are applying 5 volt, but instrument is applying actually 10 volt. This 10 volt is called as a compliance voltage. So, always the compliance voltage should be higher, so that you can do your experiment without any ohmic drop. Even though you are working in aqueous or non-aqueous, any kind of solvents, this IR drop, to avoid this IR drop, your instrument should have a little higher compliance. So, choose your equipment accordingly. Apart from many other parameters, these 3 are major parameters right now to start with. So, compact instrument, it comes with potentiostat, galvanostat with additional modules. Like if you want to perform RRDE experiment, it requires a bipotentiostatic mode, that is an add-on module. What are all the modules which are connected to potentiostat, galvanostat? They are called additional modules. So, this instrument does not provide any additional modules. They are simple potentiostat, galvanostat, no additional modules. Compact instrument can provide you additional modules, but it is limited to only one module. In the modular setup, it is the same single channel equipment, one potentiostat, galvanostat will be there, but you can connect n number of modules. In the same equipment, you can measure EIS, in the same equipment, you can do RRDE experiment, in the same equipment, you can do EQCM experiments. Many modules you can connect in the same equipment, you need not to buy different equipment. So, in the multi-channel equipment, you can go more potentiostat, galvanostat channels along with the modules, or only the potentiostat, galvanostat modules. So, with our Metro Motor Lab system, you can go up to 12 channels. So, either you can work on 12 potentiostat, galvanostat or 6 potentiostat, galvanostat with the 6 impedance module. Whenever you add a module, it also occupies one channel slot. So, with this electrochemical workstation, what are all the type of cell connections are possible? All the instrument comes with 4 cables, with one more cable called ground. So, 5 cables will be there. One is working, One is reference, another one is counter, and another one is working electrode 2 or sense. So depends on your application, you can convert the connections in such a way that you can use it for your application. For an example, this 2 electrode setup where we will be using in energy, in batteries or supercapacitors, you will be using only anode and cathode, only 2 electrodes are there. But in case of basic electrochemical works or fundamental electrochemical setup, you need 3 electrode setup, working electrode, reference electrode and counter electrode. And 4 electrode setup will be used mostly in RRD, bipotentiostat, HER, OER, water splitting, for those experiments. So same equipment can be used for multiple applications which can handle different cell connections. So this electrochemical workstation can work in different sectors. So we have designed basically 4. One is energy sector, which comprises of all battery, supercapacitor, solar cell, photovoltaics, and then corrosion, polarization resistance, Tafel plot, polarization current, life of your sample, all these things can, pitting corrosion, all this can be done with the electrochemical workstation with the corrosion setup. And sensors and basic electrochemical fundamental research, and then last is voltammetry and stripping voltammetry. That is a separate instrument, but that will also works under electrochemical principle only. It under material will undergo oxidation or reduction under the particular condition. But these 3 sectors we will be covering with the electrochemical workstation with the potentiostat and galvanostat modes. In energy we are going in deeper. In energy sector we are again subdivided into batteries, coin cell, cylindrical cell, pouch cell, pack. Apart from that, you can have a modular batteries, bigger batteries. But with this setup, you can study up to pouch or pack cell. That is possible. But for bigger batteries, it requires more voltage, more current. So which may not be possible with this kind of instrument. Then you need a bigger instrument where it can handle 100 volts, 100 ampere. So it requires, it deals with very high ratings. So that is not recommended in lab. And fuel cell, even if it is a small cell with the hydrogen evolution reaction, OER, with your catalyst material, electrocatalyst, and then solar cells, photovoltaics, all this can be studied with same equipment. You need not to do any modifications. Depends upon your work, we have to change the sampling accessories. So coming to battery, what is battery? In a simple way, battery is consisting of 2 electrodes and electrolyte, which is separated by a separator, and it is having a current collector. So in a simple way, these 2 are current collectors. These 2 are current collectors. One is anode, cathode, and this is a separator. This is how a simple battery system will look like. In batteries, we have 2 different types. One is primary battery, another one is a secondary battery. In primary battery, we cannot do recharge. It is a single time usage. In secondary battery, we can do charge as well as discharge. You can use it multiple times. So why many people are now working on batteries? Because battery has many applications. You take any material or any electronic device now, without battery it is not coming now. So everyone is interested to battery, and people are changing the battery chemistry to go for more power density, more capacity. Now I am doing one charging and it is long lasting for 8 hours or 10 hours. So still people are doing some research to increase that time. If I do charging after 6 months, I should not do anything. The battery should long last. So those kind of materials, those kind of research are going on in battery. That's the reason battery is a never ending field. Always there will be a research, always there will be a development. So if you see the battery trend, the first battery research and publication started in 18th century with the lead acid. The first commercial battery came nearly 1820 or something. Later people have changed to different chemistry. From the lead acid, lithium ion batteries have started, and then rechargeable batteries have come. So many research are going on, and last 5 years or 10 years battery is gaining more and more requirements. Now we are moving from fossil fuel like petrol or diesel, from there we are moving to battery again. It's an alternate source of store energy. So nowadays you can see many automotive vehicles, they are coming up with the batteries or alternate fuels. So everywhere there is a requirement for battery. That's the reason battery is a never ending field. Always there will be a research. People are always trying to go beyond. Okay, now I have done something, but I will need a better one. So there is a chance battery is a never ending field. So if you are planning your future, you can choose this as one of your field. So in battery, how this equipment is going to be useful for you. So in few slides back, we have seen battery is consist of anode, cathode, separator as well as electrolyte. Either you can do individual characterization of your anode material, how my anode material is, how my cathode material is, how my electrolyte is behaving, how my separator material is behaving. You can study individually when you are doing at a research level. Once you have developed your battery or you want to do reverse mechanism something, in the full cell also you can do the complete characterization. So in this way, this equipment is going to be useful for your battery research. So what are all the parameters, what kind of studies we do? So any techniques, these three parameters will be minimum requirement, I would say, maybe two parameters, CV, which is nothing but a cyclic voltammetry, and charge discharge, and EAS, electrochemical impedance spectroscopy. So why we do CV, why we do EAS, what kind of information it gives with respect to battery. So CV, you can find out your reaction mechanism, redox behavior, as well as electrochemical reversibility of your reaction. Once my product is transformed to some other element, but again it is reversible or not. Then what is the potential window? I am doing one metal and I want to know at what potential I can do my charging or discharging. What is the maximum potential I can go or what is maximum current I can go. So by doing this CV, you can get all these insights. Based upon this, you can fix a particular potential, you will come to know what is the redox property of your material. Then with the galvanostatic charge discharge, you will get the battery capacity, coulombic efficiency, cycle life. So battery capacity, what is the capacity of my battery? After doing my 100% charging, how long it is stable? If I am doing 5000 cycles charge discharge, after that also whether my battery is stable or not. So all these parameters we can get the information by doing charge discharge study. Next is EAS, electrochemical impedance. This is more on electrolyte as well as separator or solid liquid junction potentials. So EAS will give you internal resistance, charge transfer resistance, diffusion behavior, and chronoamperometry. It's a reaction kinetic under constant voltage or current. Nowadays people are doing different technique. It is called this PITT and GITT. It is always there. It is slightly different from charge discharge. In charge discharge, you apply a constant potential or constant current and you do charging and discharging. But in this potentiostatic intermittent technique, titration technique, they do the charging or they will apply the constant current and they will wait for some time. While they are waiting, it will be on OCP value, and during waiting also they will evaluate. So from 10% to 15% I have charged it. Now I am not doing charging. I am waiting for 5 minutes. Whether that 20% is remaining there or it is coming down or still it is increasing because of the heat energy or side reactions, what are all the other problems during my charging. So this technique is also very useful. So majorly we will be doing CV, galvanostatic charge discharge, and EAS. Apart from that, this PITT and GITT. So this is how the lithium ion battery will look like. In anode, you will be having a graphite with lithium modifications or some metal modifications, and cathode also you will be having a lithium based lithium metal oxide, like lithium cobalt nickel oxide, or different composition is there, and in between you have a separator and you have a electrolyte. So during charging, what happens? From the anode, the lithium will be moving to your cathode, and during discharge again the same lithium is coming back. So this is how the internal process behaves. So to study this battery characterization, we need a proper electrochemical workstation as well as the proper cell setup. So what are all the cell setups available? For an example, if you are working on coin cell, we have a coin cell holder. So the normal coin cell holders which is commercially available will be a kind of a press type. So you remove your coin cell holder, keep your coin cell and press it. So if you do 5 or 10 times, then after you press also the contact may not be established properly. So you are not sure whether the data what you are getting is correct or not. So with this gold plated coin cell holder, you can just press your coin cell inside this and connect the cables here. There won't be any extra resistance, and whatever the data you are measuring, it is from coin cell only. This is one such accessory. Second is, when you are doing some lithium based battery developmental works, lithium you cannot work at room temperature or outside. It is dangerous, it is explosive in nature. So people will do all their preparations or fabrication work in glove box. So you can take this cell inside the glove box, add your material and close the cell. Then you can take out the cell out, you can connect it to our equipment, and then you can vary a temperature, different temperature, and you can monitor your property of conductivity, impedance at various temperature, so that you can evaluate the battery material property with different temperatures. This is one accessory. Apart from that, we are providing Swedlock cells and battery rechargeable battery holders. So with that you can connect a proper cell to get a better data accuracy, repeatable data. So today we are going to see one charge discharge with the supercapacitor. We are not having any rechargeable battery, so we are going to demonstrate with the supercapacitor. So when it comes to charge discharge, with the battery there will be a different rating. Any guess what is the battery rating? Any values? You have seen this 2A batteries or 3A batteries which is used in remote or some other equipments. Any idea? Some values they might have mentioned: 2 volt, 2000 milliampere per hour. So that is the battery rating. Then comes a parameter called CV, C rate. What is C rate? To reach a complete capacity of the battery per hour, that is 1 C rate. For an example, if you charge the battery at its full capacity, if you need 2 amps per hour, that is 1 CV, 1 C rate. If I do the charging at 2 C, instead of 1 C, if I am applying 2 C rate, then the battery will be charged within 30 minutes instead of 1 hour. Instead of 2 C, if I do 5 C, then it will reach its charging capacity within 20 minutes. So now people are started doing research and they have come up with the very good products. That's the reason in nowadays we are seeing different mobiles with high charging, fast charging. You connect it within 5 minutes, it reaches 80% of charge. After that, it will charge very slowly. So they have developed the materials and they have programmed in the battery management modules in such a way that from 0 to 50 or 0 to 60, it will do 5C charging. After that, again it goes to 1C charging. So that at least 50-60% you will reach within very short time. So people are doing more research on that. But if you do this fast charging, there will be a loss or there will be a 50% reaction in the electron transfer. So instead of the complete lithium moving to anode to cathode or cathode to anode, it will be polarized in nature, which is decreasing the efficiency of the battery. So that's the reason people are doing more research. I want to do fast charging, at the same time my battery life also should not go down. So because of based upon this also people are doing many research. They are modifying the material, cross linking, they are changing the electrolyte. So that's the reason battery research is gaining more and more need and requirements. So these are all some of the application notes which we have already published in our website. It is open source. You can download all this and you can study at your leisure time. Why we need to do EAS. If the EAS curve is this, what could be the interference? Why I am getting this kind of EAS? What is because of what this is happening? So if I am doing charge discharge, what is the values I am getting it? All these details are there, basic theory details. You can go through this. So I'll stop here. I'll start this experiment and then we will. The software what we use is Nova, and there is no multiple licenses. It is lifetime license, and you can install this Nova in multiple laptops. You connect with the equipment and then you copy the data, you install this Nova software in your laptop and you can do the data processing, data representation for your paper publishments. That is also possible. There is no restrictions. So moment you open this library, you will get a default templates for your methods. So what are all the modes the instrument can perform? All those modes will be listed here. If you see cyclic voltammetry, linear sweep voltammetry, voltammetric analysis, chrono methods, EAS methods, all these ready-made templates are there. Just click I want to do cyclic voltammetry. If you are doing a cyclic voltammetry, potentiostatic or galvanostatic, just select this, then you will get a method template. Depends on your material or depends on your requirement, just click this CV and enter the parameters. This is what you might have seen in the first session. So here we are going to do galvanostatic charge discharge. So I am going to chrono methods, chrono charge discharge. I am having a default template. I am opening it. So first, this is the cycle. This is called one cycle. First, it will apply a particular current to charge your device. Once it reaches the complete charging or cutoff value, then it will move to discharge. Same way, during discharge, it draws current from your device. Once it reaches 10% or the specified value, which is called cutoff window, it stops the discharging and again it goes for the next cycle. So here, depends on your battery or device, you can give a different current values. So this current values is what we are discussing, 1 C rate or 2 C rate or 5 C rate. So this is one cycle. Here you can mention repeat. So how many times you want to repeat this cycle? 10 times or 100 times or 200 times. Normally the battery researcher would be doing it multiple times, not for 100 or 200. So they will do more than 1000 or at least 1000 cycles to find out the characterization of the battery or stability of the battery. So in our equipments, our normal electrochemical workstations are capable of doing up to 2000 to 5000 cycles maximum, not more than that. So when you are doing any experiment, don't put 10,000 cycles at a time. So normally how the software behaves, it measures your data, it collects, and then once the process is over, it stores the entire data as a single file. So when you are doing 10,000 cycles, what happens? It produces huge data. So software carries data, and after some time it may not respond. So each software has some limitation. With our software, it can store up to 1 lakh data under temporary memory. If you are exceeding that 1 lakh data, then the software hangs or sometimes it closes abruptly, then you will lose all these data. So if you need a 10,000 cycle data, there is another option. We suggest you to do a scheduler or a sequencer. So you prepare a method with 1,000 numbers, 1,000 cycles, that you can repeat it 10 times. So once it completes as the 1,000 cycle, it saves as a one file. So that even something happens at 1050, you will have at least 1,000 cycle data to evaluate. So this is way you can reduce your file size and you will not lose any of your data. And during interpretation, you can combine all the file data continuously. That option is also available. So right now we are adding a 10 cycle. So I am going to apply 0.075 amps. This is at 75% of charging. So at this rate it is going to charge, and point negative 0.075 amps. This is for discharge. So the leads are connected to electrode setup. Working electrode and sense is connected to positive. Reference and counter is connected to negative. So battery is also connected in the same way. So in the live, you can see how many cycles are running. Now 1 of 10 it is showing, and in the sequence, so first charging is done. Now it is doing discharging, and another 90 seconds is remaining for discharge. Either it will do the discharge for 100 seconds, or if it reaches the cutoff value, it will stop and it will go for the next step. So you can do it in two different ways. So normally when you do this charge discharge, you get this kind of data. So initially it will be at some current voltage 1.5, then it is charging, it goes up to 4. So I have given cutoff as 5. So this supercapacitor is rated for 5 volt. So I am not going to touch the 5 volt. At 90% I am stopping the charging. Same way, 0% I don't want to discharge, I will stop it at 10%. So I am coming up to 1 volt, then I am again going for the next cycle. So this is how all your data, charge discharge data will be there. So this data is collected for I think 7 cycles. Maybe if you collect 10,000 cycles or something, then your this is one data performed for 1000 cycles. So what we infer from this graph, when I am doing the charging, how fast it is charging, getting charged with respect to time, whether it is charging very fast, and during discharge how fast it is discharging. So in titration technique, they will stop at particular point and they will measure the stability. So if it is charging for a longer time, then it takes more time for your charging instead of this way. So this C rate depends on the C rate, this pattern can change. So I will show you one more data. So this data generated for a battery at a different C rate. If you compare this 1C and 2C, 1C is red color, this one, and this is 2C. So if you do at higher C rates, it can do fast charging or discharging, but at the same time if you see the capacity or power density values, there is a change. So the capacity will slowly reduce. So normally charging or discharging at a higher C rate is not recommended. You can reduce less than 1 C to increase the stability of the battery, but still people are doing more research on this. Even though I am doing higher CV or C rate, the stability should come better. So this is all about battery and charge discharge details. Right now we are doing it with the supercapacitor. Any idea what is supercapacitor? Why people are doing research on supercapacitor? You have seen this supercapacitor anywhere in your devices? Electrical bus, train tracks, very good, regenerative braking systems. Then wherever there is a requirement for high power within a short span of time, when you start your car or when you start your scooter, it requires a huge power. So if you draw the entire power from battery, then the battery life will reduce or the battery may not support sometime. That is the reason your self start will not work several times. So when you do keep on taking a huge amount of power from the battery, after some time the battery power will be reduced. So if you give the scooter in the mechanical shop, what they do? They recharge the battery and they will provide. Again the self start will work. So instead of, to avoid this, nowadays we are using the supercapacitor. So the huge amount of power will be released from supercapacitor, and then for your normal routine they use the battery. The best example is automotive. Nowadays the battery vehicles, two-wheeler or car, for the initial startup or whenever you are climbing a steep rise hill area, there it consumes a huge power to run your engine. So in those conditions it can draw the power from supercapacitor. Supercapacitor can give power at a stretch. It cannot give slowly. It will release the power at a fast, at the same time it can recharge at very fast speed. So this regenerative braking system is nothing but you are going at the speed of 50 kilometers per hour. When you are applying the brake, there is a energy change. So that energy is converted to current and it is stored in the supercapacitor. And whenever there is a requirement, the engine start, this supercapacitor will produce that energy, and for your regular operation the battery will provide you the current. This is one. And second thing, if it is a huge industry, in your house whatever the UPS system you use with the inverter, it is made of battery. So moment the power goes, the inverter gets the battery power into the line and you will get the tube light. If you see this fraction of second, your light will go down or there will be a small trip or the power goes down. In an industry scale, if the power goes, if there is a trip for 1 second or 2 seconds, that is also loss for them. The instruments may stop, the machineries may stop. So they don't want to stop this. So in these cases, they use a huge supercapacitor pack, like your UPS battery. They use a huge supercapacitor pack that gives the instantaneous energy. After that, your generator will start. So once power failure occurs, the generator start may take within 1 minute. So within that time, the supercapacitor will provide a huge energy to take care of it. And then the camera flashes. All this flashlight, instantaneous power, it requires a huge power within a short span of time. So those powers, it comes from supercapacitor. So parallelly battery, now supercapacitor is also getting more and more requirements. So that's the reason people are equally working on batteries as well as supercapacitor.
So they cannot be used without battery.
They can use. They can
Don't
use.
have that much output like battery.
Yes. See, even in your laptops or some equipments, moment it starts, the power supply unit will have a capacitor. So that gives more power to power supply board and then the instrument starts. After that, it doesn't require any power. The power supply board regulates the constant power and then it distributes to entire system. So there is no mandatory rule that supercapacitor will always require a battery. Only supercapacitor can give a, only thing is it can charge quickly, at the same time it can discharge quickly. It releases the power at a stage.
That is a disadvantage.
Yes. So this is one data we have generated for more than 1000 cycles. So if you plot these values, this is a discharge and this is a charge, and you plot these values against either capacity or power density with respect to C rates with a third party software. As of now we do not have that feature. So this data we have to export in Excel, and with the formulas available we can directly convert these values to power density and versus capacity values. Then we can do the characterization. So through CV you will do the reversibility or your redox mechanism, and then you can fix the window. With this charge discharge you can come to know the stability of your material. So apart from that, this solar cells, photovoltaic cells, all this comes under energy storage, and even the fuel cells. So we can do those characterization studies also. So photovoltaics or solar cells, normally we do IV characterization. So solar energy, what happens? The energy of photons are converted to current and then it is stored. That is solar cell. So how we are doing it manually? There are solar simulators are there which can simulate the original sunlight under a lab condition. That is called solar simulator. So there will be a two combination of instruments, solar simulator plus potentiostat galvanostat. So through the solar simulator you can apply one sun current, the artificial sun energy can be created, and then you can evaluate your material. If photons are flowing this power, how it reacts, how much current it generates, how long it stores. This is photovoltaics or solar cells. And fuel cell, you can study directly the full fuel cell. So this is our fuel cell, how the setup will looks like. So there are multiple chambers are there, whereas you pass the gas, maybe with a different, yeah. You pass the hydrogen gas, and then it comes as a water outside in the anode compartment, and you have a electrolyte, and then cathode is there, whereas you are purging only oxygen. So through this, the ion movement, electron flows through cathode to anode, thereby you are getting a power. So this is a simple fuel cell, how it works. So this, for this fuel cell we are using a catalyst material which helps in proton transfer. So you can do this electrocatalysis, that is called comes under water splitting, HER, OER, all these studies can be done with the same experiment with additional modules. So this is a setup called RRDE. So you can drop cast your catalyst material in GC electrode, and then you can rotate this electrode at various speed to study your hydrodynamic property of your catalyst. And apart from this energy storage, we do corrosion studies with this electrochemical workstation. Corrosion can be studied with your SS material or different metal coupons, and nowadays this corrosion is also getting more and more requirements. People are developing many metals with the different coatings. You take your simple two-wheeler or car, they are having a metal with the different paint coatings. So with the normal exposed conditions, or if scratches happen, how the rusting is happening, how fast it is getting corroded. If I coat yellow color paint, how it is corrosive resistant. If I coat white color paint, how it is resistant. The color is not a matter, but the pigments or the chemical composition of your paint, that takes care of your corrosion. They are called inhibitors, corrosion inhibitors. So people are studying many of this kind of researches also with the same corrosion electrochemical oxidation. Normally it is used now for battery. We are seeing the CV, EAS as well as galvanostatic charge discharge. But in case of corrosion, we will be doing LSV and EAS mostly, and then pitting corrosion. All these parameters can be analyzed with this electrochemical oxidation. Last but not the least, this biosensors. All your biosensor are medical devices. Wherever we go to this diagnosis setup, you are giving your blood, they are providing a result for urea, creatinine, many parameters they are providing. Earlier, those reactions are done manually with the spectroscopy method or different methods. Now everything has been changed to electrochemical method. So inside that they are having a sensor. It is called screen printed electrodes. So each screen printed electrode will have a different material, carbon or gold or platinum or silver, depends on the requirement. So you place your sample of blood or supernatant plasma or whatever the solution it is. The simple example is glucometer. So you pinch it and place a drop. What happens? Inside the glucometer, it runs one CV, and it find out the peak height at 0.6 or 0.4 volt. At 0.4 volt, the glucose will undergo oxidation. Glucose will convert into some other form. Because of that, you will get a peak. If your peak height is this, your glucose value is 100 m. If the peak height is different, then your glucose value is 120. Like that it changes. The same thing is happening in diagnostic devices. So those sensors also, nowadays many are electrochemical parameter. Some are based with the CV technique, some are based with the LSV, some are based with EAS. So this electrochemical oxidation is useful in many ways. So this is one short explanation about electrochemistry, and today for battery you are seeing three different sessions: CV, impedance and charge discharge. So any questions, please. Otherwise you can contact us through our website. You can send any queries, info@metrom.in. We will be there to respond to your queries.